So mass and time are used, but not that in that manner in which it is used in the derived quantity. So current is a fundamental quantity but an auxiliary fundamental quantity. Similarly, the intensity of light involves the electromagnetics. These electromagnetics again uses some phenomena that are related to mass, time and length. So these are auxiliary fundamental units. Similarly, temperature and amount of substance involves mass, and temperature involves mass and time as well, as per the modern physics rules. So these quantities are termed as the auxiliary fundamental units. Length, mass and time have fundamental units as meter, kilogram, second, but these international systems of CGS can also be used, and foot, pound, second can also be used. So these systems are all fundamental systems, and these are used worldwide. Fundamental physical quantities are 7. We have length, mass, time, temperature, amount of substance, current and intensity of light. So 7 fundamental quantities, 3 fundamental basic units, 4 fundamental auxiliary units. So this is the new information that we are adding to our arsenal of knowledge, that auxiliary fundamental units are current, intensity of light, temperature and amount of substance. Okay, these units are also given in here as kilogram, meter, Kelvin, amount of substance as mole, amperes, seconds and candelas. So candelas is from candle, so that's why we can clearly know that it is the luminous intensity. Okay, moving to the next slide. The measurement units can be either fundamental or derived units. So derived units are those which can be expressed in the dimensions of fundamental units. So dimension of length is L, and this area can be meter square, which is L square. So fundamental units have their own dimension, derived units have the dimensions replicated from the fundamental units with some combination or multiplication or division, etc. So if we check these quantities, area is meter square. Similarly, momentum is this is m, and this is L, and this is T inverse, and these are secondary fundamental units. Secondary fundamental units contains derived units, secondary derived units. These are containing a derived units and a fundamental unit. So derived and fundamental makes a secondary derived unit. So these are the third category units. So from this area onward, we are having secondary derived units, and these are only derived units. So you can check these quantities. Similarly, from here to here and then here. Okay, so these are the secondary derived units. Newton is involved in this these units. Resistance, voltage, flux, etc. Are electrical quantities which are our derived units in this case. Now, standards and their classification. Standards of measurement is a physical representation of unit. So physical representation of mass would be a kilogram. So kilogram is a standard. The unit is utilized by reference to an arbitrary material. Arbitrary means any material that we can suppose, but that is a bit controversial, because this arbitrary material must have constant properties and characteristics. It should not change with respect to time, or we should with respect to time and temperature and anything, or we should define some constant phenomena for it. So we standardize it. So standard units can be like the one for second, which is defined as these much vibrations of cesium-133 atoms, and also the 1 meter is defined as the 1/299799245 and 1/8 of a second. So if we take 1 second and then divide it by this much quantity, and we calculate that how much light is passed, how far the light is gone in this much time, so that would be a 1 meter gone light. So this is actually a very defined thing now, because light's speed is constant, and we have suggested that how much distance would be traveled by a light particle if the time is kept at 1 divided by 3 into 10 power 9 of a second. Okay, so this rounds off to this thing. That's why I have written this. So this is the classification and standardization of unit. We are having different standards for instruments as well and units as well. So the basic standard that we follow are the international standards, and these are never touched. These are kept inside a lab. Primary standards are also kept inside labs. Secondary standards are somewhat accessible, and working standards are accessible to all. So we will deal these 4 things in the next section, so you will understand these things then. Okay, so international standards are defined by an international agreement, and the units that are then defined based on these international agreements. So we actually make definitions for specific quantities, and then these quantities are well calibrated and checked and kept inside labs, and these quantities are then termed as the fundamental quantities, and these units are known as the fundamental units. So if we have even a quantity that is derived, and this quantity is kept inside a lab and it is defined by some international standard, that will become an international standard unit. Okay, these standards are maintained in the International Bureau of Weights and Measure in Paris. So these are for the comparison and calibration purpose. So if we have some international standard, that international standard would be defined by an international agreement, that 1 kilogram is a platinum iridium alloy bar which has a value of 1 liter water, and it has a temperature of 4 degrees, I guess. So this is an international agreement, and upon this agreement a bar is kept in this lab, and it has become an international unit. Now, what is a primary standard? A primary standard is maintained in the national laboratories in different places. So this is a bit accessible, and these are not necessarily for fundamental quantities, so they can have derived quantities as well kept in the international lab. These are for calibrating secondary instruments. So these are accessible instruments. That kilogram in the Paris is not accessible, but these primary standards are now accessible. Similarly, the secondary standards are generally sent to these primary standards for calibration, and these secondary standards are used as a reference in the industry. So these are the units that are kept inside a factory, and other things are calibrated with it. So this will mean that if we have 1 meter rod kept in the industry as secondary unit, other meter rods would be compared with this meter rod. So this thing is now accessible, and this thing was compared with the primary. So this was checked with the primary, and it is checked periodically with the primary, and then it is kept inside industry for producing some more instruments. Okay, these standards are maintained by the particular involved industry and are checked locally against the reference standards. Okay, the responsibility for maintenance calibration rests entirely with the industry lab. So these are kept inside industry and are periodically checked with the primary. Working standard are the principal tools for measurement labs. So they are used to check and calibrate general lab instruments. So we had industry. In industry we prepared some units, and those units are termed as the working standard. So the industry will supply those working standard to labs, and then we can further use it for our own usage. So for example, we are having some resistance in our lab, and we take a wire and compare it with that resistance and flow some current to these both resistance. So let's say we supply some voltage to it, some current to it, and then we check that when will this ammeter give same result as this one. So when both resistance and this wire give same result, we say that this resistor is equal to this manufacturer's provided result. So this is a demonstration of working standard, that we are having this as working standard and we are creating our own things with these working. So making our own resistor in the lab is by usage of a working standard, a resistor that is bought from a shop. Now coming towards the method for measurement, there are two types of method: the direct comparison method and the indirect comparison method. So in direct comparison method, we are having two further methods: the deflection method and comparison method. In deflection method, we measure some quantity by calibrating it with a scale, by checking it on a scale. So this can be a direct method. For example, we use some spring inside, let's say, this structure, and then we use some weight in it, and here is our needle, and this says that it is 0 gram, and here it is, let's say, 100 gram. So if we place something here, this will go here, and this will directly show us that how much grams this thing is. So this is previously calibrated with it, and now we are using it for our direct measurement, Now if this thing is treated as grams, then this will be direct measurement. If we say that if this length of the spring is 0.5 meter, then it will be 0 gram. If this length is 0.7 meter, then it will be 20 gram. Now that this is a bit indirect method, because we are calculating grams from length. So this is pretty much clear from this example. In comparison method, we are having two quantities, and we use one quantity in comparison with other. For example, if you want to know the EMF of unknown quantity, what will we do? We will compare it with a standard cell. So by doing that, we can know the difference between these two quantities, which will lead us towards the calculation of the unknown quantity, and in the end of the